Hi Year 12s! This is a review video to remind you of some of the rules of sketching quadratics. The basic shape of a quadratic or parabola is a U. The basic equation is y equals x squared. When reflected in the x-axis, the equation becomes y equals negative x squared. To get this graph, we just flip the graph of y equals x squared upside down. Keep these basic shapes in mind whenever you are graphing quadratics. Now we will look at an example of the classic quadratic equation, y equals ax squared plus bx plus c. The easiest way to learn how to draw a quadratic is to do an example. So let's do this one. Y equals 2x squared minus 13x plus 11. Just like a linear graph, the first step to graphing is to find the x and y intercepts. To find the y-intercept, we let x equal 0. It is always a good thing to write find y-intercept, make x equal 0, before you start the working out. This is so the examiner knows exactly what you are doing. When we have the graph in the form of y equals ax squared plus bx plus c, the y-intercept will always be the c value, which in this case is 11. To find the x-intercept, we make y equal 0. We'll start by writing find x-intercept, make y equal 0. When we have the graph in the form of y equals ax squared plus bx plus c, we can find the x-intercepts by factorising into two brackets and using the null factor law. Alternatively, we can use the quadratic formula. Here, let's use the null factor law. Let's start by letting your equation equal 0. So we get 0 equals 2x squared minus 13x plus 11. To factorise, we'll use the cross method. To do this method, we just guess and check our factors until we achieve the function. For instance, to get 2x squared, we need 2x times by x. And to get 11, we need 1 times 11. Given our b value in the function is negative, one of the values at least must be negative. Given our c value is positive, we know that both values must be negative. Straight away we can tell that we need to multiply the 2x by the negative 1, since if we multiply it by 11, we will get too large a b value. Therefore, when we times x by negative 11 and add them together, we get negative 13. This gives us the brackets 2x minus 11 and x minus 1. So, after using the null factor law to solve, we end up with x is equal to 11 over 2, or x equals 1. Once you have your x-intercepts, make sure you write them down as coordinate points. In this case, the coordinates of the x-intercepts are 11 over 2, 0, and 1, 0. Remember that some graphs will not have x-intercepts. This happens when the graph is entirely above the x-axis or entirely below it. If you are interested in using the quadratic formula method, please have a look at the notes on our wiki under the same section. Now, step 3 is to draw the shape. Now that we have 3 points, we can plot these in our graph and join the dots to draw a curve. Step 4 is to find the coordinates of the turning point. We can do this by first finding the x-coordinate of the turning point. Since we have both our x-intercepts, we know that the x-coordinate of the turning point is exactly halfway between these. In this case, we find the halfway point by adding both x-intercepts together and dividing them by 2. So, we now know that the x-coordinate of the turning point is 13 over 4. Just a note, keep all numbers as fractions. Once we have the x-coordinate, we can substitute this into our equation to find the y-coordinate. This will give us y equals negative 81 over 8, and so our turning point will be 13 over 4, negative 81 over 8. If you do not have x-intercepts, we can find the x-coordinate of the turning point by using the formula x equals negative b over 2a, where the coefficient of x squared and b is the coefficient of x. Since a equals 2 and b equals negative 13, we get x equals 13 over 4. We can find the y-coordinate of the turning point the same way as above, which was to substitute the x-coordinate back into the equation. Before you move on to the next question, make sure your graph contains the following: all intercepts, x and y-axis are labelled, the turning point, and the correct shape. In the exam you'll get marked on shape, so it might be a good idea to spend some time practicing your graphing technique. Sometimes the equation may appear in what we call turning point form. Y equals a times x minus h all squared plus k. This is just a form which lets us know where the turning point is straight away. In this equation, the turning point is just x equals h and y equals k. Note that the negative is ignored in front of h. To draw the rest of the graph, we go through the same process as above, of setting x to 0 to calculate the y-intercept, and then y to 0 to calculate the x-intercept. If in doubt, you can always put your equation in the form ax squared plus bx plus c by expanding out all the terms